In this video, I'm going to talk about the next levels of the Angry Birds Lost in Space Gauntlet, the Platinum, Sapphire, and Black levels, and the basic idea behind them. So, in the Platinum level, we want to calculate the acceleration due to gravity at the surface of a non-rotating planet. Planets actually do rotate about their own axis, but we'll start with the simple case with just a mass that's not rotating. So, if I have my planet here, and you can see it's kind of bulged, kind of elliptical, because most planets have a slight bulge because they're rotating about their axis, although in this case we're going to consider it not rotating. But there's a center here. I'll call this the radius of the planet, r. And the reason why this is important, the bulge, because the distance from the center to the equatorial point is different from the center to the poles because of the slight bulge. Okay. At any rate, let's say I have an object, or your Angry Bird here at the surface of the planet, right there at the surface of the planet. We want to use the mass of the planet here and the radius to determine the gravitational acceleration at the surface. So, for instance, we know g on the Earth is 9.8. We want to find it of the planet that your Angry Bird is orbiting, and we're actually going to do it to about 5 decimal places. So, here's the strategy. I'm going to draw a free body diagram of the Angry Bird at the surface of the planet in question, and so I'm drawing this sideways because of the way I've drawn the picture here. This is an equatorial point. So this is my f of n. Okay, if you want to rotate this 90 degrees when you do the work, that's fine. I'm just keeping it in the same orientation. This is the force due to gravity. Now normally it's mg, but now because we're dealing with Newton's universal law of gravitation, this is going to be g, capital, that's a capital G, capital G, m over r squared. Okay. The next thing I would do would be the next step of the force model. That's step 1. Step 2 would be to sum the forces. So we sum our forces. And the strategy is, in step 3, is we're going to solve for the normal force, which is the force on the ground. And then to get the acceleration, if we take the force divided by the mass of the Angry Bird, that should give us the acceleration rate. Okay, so that's the strategy. Free body diagram, sum the forces. And then solve for the f of n, which would be like the ground or a scale on the ground, which would read your weight. If you divide by the mass, you get your acceleration rate. Okay, so that's the Platinum level. Solve for the acceleration rate, and we're going to do it to 5 decimal places, 5 points of precision. Okay, and then you can actually, to see if you're in the ballpark, look at Wikipedia, which has about 3 or 4 decimal points, to see if you're correct. But we want 5 in our answer. The Sapphire level. Sapphire level. So planets actually do rotate about their own axes. So again, let me draw the equatorial lines here to make it look a little bit 3D. Now the Angry Bird's still here at an equatorial point, okay, and it'll orbit around. If the planet orbits around, it'll go like this. All right, and the hint here is that we're going to use the same methodology, except that we're going to deal with, if you look at top view, this is actually traveling in a circle. There is a centripetal force that's acting on it. Okay, so we're going to sum our forces, and we're going to use the concept of centripetal acceleration because this object does have a velocity, it does have a radius, and from that we can use our force model, the centripetal version of our force model. If you look at the assignment, the actual Gauntlet on the website and the description, we have to know some information. So the radius we know already. The radius from we can get, and all this information I'm using is from Wikipedia, which is pretty close, but not exact to data from NASA, so it's pretty accurate. And we also know how long it takes for the object to go around, the period of motion. And this is called the sidereal period, and you can find this on Wikipedia for every planet. And it tells you the time it takes an object to go around, or a planet to orbit, one complete time. So the sidereal period. So that's a time of rotation. So the hint here is that we have something to do with centripetal acceleration, sidereal period for time. And if you look down, top view, this object's traveling in a circle, okay, of radius r. It's traveling in a circle of radius r if you look down from a top view. Okay. The last level, the black level, is called the balancing act, and the basic idea behind it is this. So we have the sun here. We have, that's the sun at 5. We have your planet that your Angry Bird is orbiting. You found in the gold level. Let's say it's Mars. And here's Pluto. And the goal is to determine how far from your planet, let's say your planet was Mars, how far in between your planet and Pluto you must put your Angry Bird. I'm just going to pick a point right here. right there's your Angry Bird, so that the forces from Mars acting this way and the Pluto acting this way are equal and they'll be balanced. Now that's just for a snapshot in time because obviously these things are orbiting around, but for this instant of time, what's the location where the forces are equal? That's the goal. Now you also see that I have some elliptical orbits. They actually are not quite elliptical. I just exaggerated here, but I drew that because we're going to look at the longer side of the ellipse called the aphelion. And again, all this data is on Wikipedia. This is the data I'm using for the calculation. So location when it's the first is the aphelion. You can think of the letter A as like away, and the point that's closer, this is the closer side, that's the further side, is the perihelion. We're going to use the aphelion. Okay, so look for the aphelion data right there. So the data we're looking for actually is the distance that Mars is from the Sun when it's at its aphelion, and the distance the center of Pluto is from the Sun right here, or Pluto. So we need to know some distances here. And the goal is to find out from your planet how far should we place the distance d so that the net force is 0. So this is a force type problem. Force problem, you draw an FBD and we sum the forces. We just have to be careful about the different distances. So that's the black level. Where can I put the Angry Bird so that it's balanced between two planets given this radii information and given the masses of the planets? So this is a briefing on the different levels, platinum, sapphire, and black level. And all these answers we'll do to 5 decimal points so we can get a pretty exact number because the data that I've given you is pretty precise.